G'day everyone, welcome to Lubrication Explained, and today, if you remember, this is my Uber driver, Danila. He's actually not an Uber driver, he is an engineer at Graco. Now, I've been lucky enough that Graco invited me to come and check out some of their equipment. I should stress, this video is not sponsored. Graco was just kind enough while I was in Europe to kind of show me around the facility, and I thought it would be a really good chance to explain some of the basics of, grease as well as oil dispensing systems, really. So Graco is kind of in the business of moving fluids around. You might actually know them from things like paint sprayer technologies and things like that. So it's not just lubricants. As much as we like to focus on our world, it's not just lubricants that they do. They spray all kinds of stuff. Tomato sauce, mayonnaise, right? Anything that is a fluid. But what's really cool about the Graco business is because they do that wide variety of fluids, they kind of have specialty knowledge in understanding how to do things like thixotropic fluids, greases, oils. So all of the different viscosity characteristics which we might see in our world, they've probably handled somewhere else. So Danila is going to join me. Danila is actually, we contacted each other because we're both ex-Mobil. Danila actually kind of started in mobile industrial lubricants around the same time I did, but in Russia. And so we're based in the Graco facility in Belgium at the moment, which has like a whole bunch of the different systems on display, so we can kind of talk through it. Now today, we're actually going to be talking through some of the basics, right, in this video, where we'll talk through, dividers, series, parallel, all that sort of stuff, progressive. We'll go through all those terms and exactly what they mean, and we'll go through the basics of that, as well as with some demonstrations. So, Danila, welcome to Lubrication Explained.
Thank you for inviting me. It's really nice to be here, really to share some knowledge about the automatic lubrication system. As Rafe mentioned, I used to be an ExxonMobil employee as well in the past, so I was in industrial sales, I was doing some mining a little bit. So right now, moving to a different field, to Graco, actually I have a chance to combine the lubrication knowledge about the lubricants, the oils, the greases, all the different varieties and the applications and the problems in the fields with the lubrication equipment. And I always say to anyone, to my ex-colleagues or my previous counterparts, I always tell them, if I knew so much about the lubrication equipment as I do right now, I would probably do my proposals differently for the customers, because it was a really big wide opener, like eye opener for me, just to see actually how the systems are different, how the pumps are different, and like what is the troubleshooting problems, because it's not always the oil or the grease that is the problem. It's also the way that they're applying it, and it also comes to the system, the lubrication system, or just the pump, or just even the hose size in the hose drill. It also plays a crucial role in the pumpability of the lubricants.
Yeah, so we're going to talk through all of that kind of stuff, right? And initially what we're just going to start with is kind of like the divider valves, right? So everyone has probably heard of what? Single line series?
So yeah,
single line parallel and series
progressive,
right? The series progressive. So let's go through the differences in them and see if we can explain actually on kind of like a mechanical level what the differences are between those two systems.
So yeah, so there are different types of lubrication systems, but I would say two major ones, especially which you see in the field most commonly. They would be the series progressive system, which consists of divider valves, so they call divider blocks, and the second one is single line parallel system. So this is the full name of these two systems. So like any other lubrication systems, the system consists of a pump, then the system consists of the metering device. So basically these series progressive divider blocks or the injectors, which we will show you later on, that they're also down here. The injectors, the single line parallel, they're all metering devices. So this is how it's called, I would say, in our world, to choose the right metering device and the technology, because these blocks, the divider blocks, they actually measure the amount and distribute the amount of grease to the lubrication point. And then you have got just hoses and fittings. So, and to control overall system, you may have like embedded controller in your pump, or it may be a separate control in your pump. So talking about the series progressive and single line parallel system, let's start with series progressive. The series progressive, it's called series progressive by a reason, because it has got a series of small plungers inside of the divider block which move one by one. So they all have to move to distribute the lubricants. So this is the inlet coming from the pump to the series progressive divider block, and this is the single line compact series progressive, we call it. It's very compact, it's relatively small in size, and it can serve up to 6 lubrication points, and this particular block. But these blocks exist up to 22 lubrication points, so one block can serve maximum 22 lubrication points. So, but here the deal, so right now, what if you don't need, all the 6 lubrication points, you just need 2 lubrication points, for example, like in this case. So you gotta use the doubling plex here to block the outlets from the progressive valve just to move the grease into the other direction. So some of you know that, in a series progressive system is if one outlet is blocked, the whole system collapses, the whole system is blocked. So yes, that's true, but in a compact series progressive valve, so there is a path inside. So when we block one of these outlets, and we call this not just plex but the doubling plex, meaning that the grease which was supposed to go here, which is all preset to 0.2 cc, each outlet is 0.2 cc, 0.2 cc, 0.2 cc. So it should go there, but in fact it actually flows like this to this lubrication outlet, but then in this blocked as well. So it goes again here until it reaches the lubrication point. So and while this 0.2 going like this to the lubrication point, then this 0.2 cannot go here, it goes again here to this lubrication points, and then the plunger here also moves 0.2 here. So meaning we are doubling the outlet here right now, and during one full cycle of the series progressive valve, the one full cycle is when each of the outlet has sent 0.2 of grease in this particular case. So meaning during one cycle we get 0.2 plus 0.2 plus 0.2, meaning this lubrication point for one particular cycle gets 0.6 cc. So the same story here. So, but it's very important here that if you block these outlets, you cannot block them. If you block them, the whole system will stop. Because even on these divider blocks, it's written there, do not block outlets 1 and 2, because if you block those, as you see here, the grease flowing like this. If you block this one, there is no way for grease to flow anymore, and then your system will collapse and the system will stop working.
Maybe if I can just interject here, just as a point of clarification, right? You said that if the outlet is plugged, then everything can't move. Now, to a layperson, they're going to say, well, these look like outlets and they've been plugged. So how is it that everything can still move?
So yeah, so this is the compact series progressive valve. So it's a special design here, so that if there is an outlet is plugged here, so there is a series of inside. You will probably see. We will have a close-up video, so you will see the series of paths inside of divider block. So if you block any of the outlets apart from the outlets number 1 and number 2, which are at the very end of divider block, it will still work, but the grease which was supposed to go from this blocked outlet is moving downwards and downwards again. So in a series progressive valve, which is a compact one, the typical outlet, it's even the same in each and every outlet. It's 0.2 cubic centimeters right now. So if this was not plugged, during the one full cycle of the divider block, it would give only 0.2 cubic centimeters outlet from this outlet. But if we plug, this 0.2 goes here, and if this were unplugged, that it would give 0.4 for one cycle. And right now, as these two plugged, and we have only one outlet on this side, this is 0.2 plus 0.2 plus 0.2, meaning 0.6. So whenever the grease is flowing, the divider valve is cycling, and it moves the grease here. The grease cannot go here. It goes immediately through the path. The volume that it was supposed to be displaced from here, it's going through to the loop point, 0.2, then again 0.2, then again 0.2. So in total, this lubrication point during one cycle receives 0.6 cubic centimeters. And to count cycles, we use the proximity switch. So this also gives us a peace of mind that if we want to measure the quantity of the lubricant we want to send, we know the displacement, we know that the exactly amount of lubricant being dispensed during one cycle. So we know that during one cycle, this lubrication point right now gets 0.6 cubic centimeters, meaning if this bearing needs 1.2 every hour, meaning that we need to run 2 cycles of the pump every hour. And this way we make sure that this lubrication point gets 1.2 cubic centimeters is using the proximity switch. Also, the proximity switch is not only for counting the volume to measure the correct amount of volume going to the lubrication points, it also gives us a feedback if system is working or not. Because, these are plugged and we can plug them, and we call these plugs doubling plugs because they double the output. So it was supposed to be 0.2, but now it's 0.4 because the 0.2 from here goes here. But if you were to block the 1 and 2 outlets, the lowest one and the bottom, there is no place to go. There is no place for grease to go anymore. So because there are no outlets underneath them, it means that the system will be blocked and it will stuck, and you will see the grease going through the pressure relief valve. So, and even right now it's not plugged, but the system, got stuck here in the line, the bearing jammed or something else happened, the grease cannot find a way, the system also will stop. And most of the cases, series progressive consists not of one divider block, it consists of multiple divider valves. So it consists of one master divider block, then which feeds to secondary divider valves. The secondary divider valves also then distribute the lubrication to lubrication points. Yeah. And if any of the system, like we saw that the case we have in Belgium, like 1,725 lubrication points with series progressive, if any of 1,725 lubrication points is blocked, the whole system is jammed. The whole system is stopped.
So in terms of redundancy, that obviously makes those kinds of systems challenged, right? So generally, those would be used on, let's say, smaller systems, right, where you probably don't have as many injection points, right? So if you have, let's say, under like 20 injection points or something like that, the likelihood that any single one of them is going to be blocked at any one time is relatively low. And once we're starting to talk about hundreds of different points, which you might see on a lot of mobile equipment, the risk that one of those is blocked becomes extremely high, right?
It's also that, but also the series progressive is being chosen. I mean, to be honest, it's lower price for the series progressive system. So it's the cheapest system, I would tell you. So it requires less components in it. So all you need is the pump and the divider block. And the proximity switch as an accessory if you want. Yeah. But I would say, people like the series progressive and the proximity switch in cases when the system is jammed and something is not being lubricated. They want the whole setup blocked. They actually want to know that any of the point is not being lubricated, because they don't want to run a machine even if one lubrication point is not lubricated. Unlike in mining, for the big trucks, there are 35 lubrication points. And to be honest, they don't care much if one lubrication point is not lubricated right now, which they could fix it like later in the maintenance time. So they rather prefer all other lubrication points, 34 points, still being lubricated. So that's why they use single parallel system, but that's later, we'll come to that.
So let's talk about a couple of things. So you mentioned that you'd probably have a few of these, right? So you have a master divider valve and then it would flow on, right? So as an example, the way that this system is set up, we mentioned that these are doubling valves. So each of these ones were going 0.6. So they would go into a divider valve which is receiving 0.6 as a flow, and it can then further divide it out. So that would be one thing. The second thing would be, like you mentioned, if any of these ports is blocked, the whole system comes to a halt. So in terms of troubleshooting, how do we find out which port is actually blocked?
That's a very good question. Thank you for that, because here you can see other option of the divider block. So this is more advanced and it's better divider block because this is a modular series progressive. So this is we call it CSP compact series progressive, and this is MSP, modular series progressive divider blocks. So the modular series progressive is a bit different from the compact series progressive, because here, even from the name, you can see it's a modular. So these are the modules. So these are different size working sections. And actually, unlike in compact series progressive, when everything is predetermined by 0.2 cc, here the working sections have different size. So they can be 20T, 20S, 40T, and et cetera, et cetera, et cetera. S meaning that there is a single, so we can use only one outlet from this working section. But if you would see a T here, it means that's a twin working sections, meaning that we can send the grease this direction and that direction. But in S section, we can only move the grease in the one direction. So here, if you plug the outlet, the system will collapse. Unlike in compact series progressive, when if you plug the outlet, you actually redirect grease to the next working side, to the next plunger. Here, you gotta use a cross-port bar, which is mounted here, which actually redirects the flow in case there is a plug installed on the working section on the base plate of the series progressive divider block. So it redirects the flow here, it's cross-port right now, and it redirects the flow to the lower working section, then lower working section, and lower working section, because you can see these cross-port bars here and then straight to the outlet. You can see also the last working section is on different level. It also an indication that there is a cross-port bulb there, cross-porting the outlet, sending the grease further. So it's probably a bit more difficult in terms of making higher the output from the lubrication point, unlike in compact series progressive, but there are more benefits to that system, because if the system fails and if the working section fails, we can just replace the working section. Or if we want to increase the output from this working section, we can replace the working section to a bigger size of it. With the compact series progressive, we cannot do that. And if something fails, you gotta replace the whole compact series progressive divider block. And also on top of that, with the modular series progressive, well, you see here the plugs. These plugs, they have a meaning for that. So actually, this plug represents this outlet, this plug represents the other outlet. So these plugs are designed to have performance indicator. So this performance indicator, there are two types of performance indicators. So one is like an indication pin here. So meaning if the grease, so to find how to troubleshoot, yes, with the modular series progressive valve. If something is blocked right now, some of the outlet is blocked right now, we want to find out which exactly lubrication point right now is not receiving grease, where is the high pressure. So this performance indicator can be set up on a different pressure. So this particular on 750 psi, but they can be on 3000 psi as well if you want. So meaning that this lubrication point right now, if this is blocked, so the grease is trying to find a way for it to flow with the least resistance. So this would be the least resistance for the grease, and the pin would pop up from here, and it will give you quick visual indication, hey, this lubrication point right now is not getting grease. So it allows you to do a quick troubleshooting actually. So you don't spend time on unscrewing the outlets, trying to see where is the pressure right now in the system. Without doing so, you can easily go and look at the divider block. And also if you do occasional inspection on your plant, you go again and you just look at the divider block and you can see the performance indicator if it's working or not. If you see every pin is just down there, I mean, everything system is working fine, you know. There are also, we offer like, we don't have it here, but we have it here, like visual indicators. Every time the plunger inside is moving here, you would see the mechanical indicator also, you know, being moved. So it also gives you a visual indication that actually the grease is flowing there, that the system is working. And it's important with the series progressive, as I mentioned, if one system is blocked, the whole system collapses. But again, if you see even one divider block is having a movement, the whole system is working properly. The whole system is sending grease. The question if the grease is receiving the lubrication point, well, that's the second question actually, because all we say that the grease is flowing through the divider valve. But what is happening there, right now we don't know. But we do have at Graco at least that we call it broken line indicators. So actually those broken line indicators can also give you an indication. You mount them on outlet. It can also give you an indication if the line actually is intact or not. Meaning that if there is some rupture of the hose or something else. So there is a broken line indicators as well. So you can all mount here. Second performance indicator, so like this performance indicator, the grease will go here, the system will be blocked, your proximity switch will not count X amount of cycles, because the proximity switch is not only to count the amount of grease we want to send, because we know the working section 20C has got X amount of grease sending to that lubrication point, and we know within one cycle, and we just multiply number of cycles to this amount, we know exactly how much grease you want this bearing to receive. Let's say, I don't know, we want a 1 cc and this is 0.2 cc, we need 5 cycles to run for this bearing to receive 1 cc per hour, for example. But also it's a feedback, because we know in average to lubricate our system it takes 5 minutes. And what happens if within 5 minutes today we didn't do 5 cycles, for example, and because it became colder, because the system is blocked, something happened, and your pump saying to you, hey man, I have not received 5 cycles within 5 minutes, and it goes into alarm mode, and then you go and gotta see a troubleshoot, because you will not see 5 cycles within 5 minutes in some day, which occasionally, usually you get to see it, usually you have 5 cycles, but if one day you don't have it, meaning that the system is blocked or something is wrong, maybe the grease is stuck or it's a cold or something else happened. This performance indicator will quickly tell you exactly if each lubrication point is stuck right now. You can do quick troubleshooting, you can do a quick repair there. But also there is a second type of performance indicator which has got a rupture disc inside, also set up on an X amount of pressure, meaning that if this lubrication point is blocked right now, the grease will start fall from this outlet, also trying to find the way with the least resistance. So the whole system will continue working. You will not see any signal with proximity switch because the divider valve will continue cycling. You will still receive signals from the proximity switch, but you will get only visual indication that actually this lubrication point is not receiving grease right now. But the rest of the lubrication points will continue getting grease. So the right performance indicator, that's the benefit of modular series progressive valve, unlike the compact series progressive valve.
And then because these are modular, if one of these is blocked, you can simply replace one of these blocks, right?
Correct.
Whereas with the compact series, you actually have to replace the entire block.
The entire block, exactly correct. So you can actually remove this, you can clean it, and then you can put a new working section. You can also use bypass sections here, which would be not used, but in case you want to increase your system, you want to add a few more points, you could replace the bypass system and sell the working sections. And unlike here, to increase the volume, we use doubling plugs. Here, you gotta use plugs, but if you just use plugs, your system will be blocked if you put plugs anywhere here. So I personally, if someone tells me like what system, I personally like single line parallel for various reasons. We will talk about them later. But per my experience, who is using the series progressive, especially I'm talking right now in mobile equipment world. You can see, you gotta see this in construction vehicles across your town, a city, that you will see the series progressive valves. I would say if your operation is not 24/7, if it's not mining, and if you work your excavator like 8 hours a day or 6 hours a day in labor, and then if you got a workshop or you have time to troubleshoot, you go for series progressive because it's more cheaper and you have time to troubleshoot. Because it requires time to troubleshoot. If something, you don't know what's happening, you need to, like I mentioned, if you don't use the proximity switch, you don't use the performance indicator, the only indication for you would be the grease coming from the pressure relief valve. But sometimes these pumps are hidden. And the operator operating the excavator may not see the pump, it's not always in his vision, and he may not even know that he has got grease going through the pressure relief valve instead of the lubrication point. So you gotta spend time on troubleshooting actually. You gotta spend time on visual inspection, like every hour or every 2 hours, every day at least, to look if it's actually working or not. Check also the oil, the grease level inside there. And also if something is going bad, you need to spend time on troubleshooting.
Yeah.
You need to find that lubrication point, you need to disconnect one by one, you need to find this. So for that, you may use the series progressive divider valves, yeah. If you have time.
Yeah.
Yeah.
Okay, so that is series progressive, right? Which is obviously a very common type. Then there was also single line parallel, right? So it seems a little counterintuitive that it's called both single line and parallel, because most people think of something being in parallel as there being two lines. So can you explain the naming convention and then how it works and why it's differentiated from our series progressive?
You're absolutely right that they're both series progressive and a single line parallel. They're both single lines, so it's always single line parallel and single line progressive system. So, but you got this single line going from the pump, it's over here, into with the injector, with a single line parallel into injector manifold. It's still one line, and you got the injector blocks, manifolds on this one line. But what is parallel here, the lubrication points, you see they work in parallel. They don't care about each other, unlike in series progressive. In series progressive, they're like a team. Everybody gotta work. If someone is not working, someone is not doing the job, then you're in trouble. Then the whole system collapses. Here in the single line injector system and the parallel system, people call it. Here, even if one lubrication point is blocked, it's not being lubricating, the other injector doesn't care. They don't care, they keep pushing. So that's also the reason why you see it very much in mining, because they still want to run the vehicle, because a 24/7 operation, they don't have extra hour just to stop because the system is not working right now. I mean, probably they should, because you have to grease your vehicle, but at least, 34 lubrication points, if there are 35, still being lubricated by the system. And then you can go into the workshop, do the oil change or fuel top up or whatever you gotta do. You can run a troubleshooting, and you can actually see here on indication pin, there is an indication pin which has to move downwards in Graco injectors just to make sure that the system is working. So you can run the system and you can go and look at your manifold and see if the actual indication pin is being moving or not.
Yep.
So the biggest difference between the series progressive and the parallel system is that here, first of all, we don't care about each other. So in lubrication points, if one lubrication point is blocked, the rest of them will continue working, the rest of them will continue getting the grease. Also, in terms of the size, in terms of the output volume, these top nuts, actually this is the adjustment nut. So we can actually adjust the output per point. Like, it's not like in a series progressive, you gotta build the system, you gotta design the system very well, because once you've designed the system, you cannot change the output just for one lubrication point.
Just to be clear on why that's the case, right, is because the volume on these systems is dictated by the size of the pin, right, or basically the diameter of the bore. Whereas here, with the adjustment screw, we could adjust that up and down while it's in operation, and that'll change the amount that it fires, right?
Yes, exactly. In modular series progressive, you could potentially change the working section, yeah, but if you're using a compact series progressive like this one, you don't have an option to do that. So it also requires less time to design a system, because all you need is just to know number of lubrication points and how they're located. You don't care about the coefficients, the sizing of the lubrication points.
Cool.
Also, the difference in the single and parallel system, unlike in series progressive, the proximity switch is an optional, is an accessory. You don't require to have it. In a parallel system, you must use a pressure switch, because basically this is an indication that all injectors fire. This is the indication that the pressure is going up, because the pump is being built up pressure in the line, end of the line, and while it's building up pressure until, like, for example, 3000 psi, 3500 psi, then it means if it builds up to this amount of pressure, it means that all injectors fired. The system, the grease is being dispensed, and the pressure switch cuts this pressure spike and sends info back to the controller, back to the pump, saying, hey, I've reached my pressure, it's time to vent. So it switches off the electric pump, and it also starts venting the system, meaning releasing the pressure. So while we release the pressure, we vent the line, and the injectors are being recharged. So you gotta use pressure switches. I've seen in the field that people sometimes don't use pressure switches because they're trying to save a little bit of money, but the problem there, if they just have the lubrication system, they installed it, they just take a timer and they say, okay, it takes 2 minutes to build up pressure for me right now, but today is like plus 30 C or something, it's very warm. Today they're using X grease, tomorrow they might be use Z grease, the different grease. So in this case, the operational time to build up pressure may change, but they don't have a pressure switch. They will not know that, and they will be running 2 minutes every day, regardless of all important factors like temperature and type of the lubricant they're using.
Yep.
In this case, it happens that not all injectors starting to fire. It means that only some of them are firing, and the rest just never, some lubrication points will never get grease, because it's just not enough time.
So that's probably like a really good tip in terms of the operation, because the pressure switch is a relatively inexpensive component, right, in the entire system, but it is helping to protect like a very expensive asset. And so this is one of those instances where spending a very small amount of money on what might seem on the face of it to be an unnecessary accessory is actually crucial to the functioning of the entire system, right? So that's kind of a really good point on the pressure switch.
Then also in the single and parallel system, you've got to use a vent valve. So you got to use a valve to vent the line, to let the grease going backwards into the pump, into the grease reservoir, so that we release the pressure to zero in the system. We will take a look also later in a typical mining setup, I would call it, with the lubrication system and with the new type of single line parallel system that Graco developed.
Just a really quick question on these, right? So the perception here is that this is a much more expensive system than the single line progressive. On the face of it, right, when you look at the divider blocks, they don't look significantly more complex, and the equipment itself is not significantly larger. So, buried inside, where is the complexity?
So, the price standpoint, why it is more expensive. First of all, like I mentioned, you still gotta add more elements like pressure switch. You also gotta use the vent valve. Also, not all pumps can work with single and parallel system, because you gotta find a way to mount a vent valve to release the pressure. Also, when you go to series progressive block, these blocks can be up to 22 lubrication points. We need to put a sign, recording in progress.
Wet paint.
Yeah.
If we say wet paint, no one will come.
So coming to the price standpoint, yes,
Yeah.
series progressive is relatively cheaper system than the single line parallel system. And the complexity there is that because in the parallel system, you gotta more components. So you gotta use the pressure switch, you gotta use the vent valve. You typically use a different kind of pump because not all of the pumps can work with the single line parallel systems. But also, if you look at the series progressive valve, these valves can be up to 22 lubrication points. So one block can serve 22 lubrication points.
Yeah.
Here, you gotta use injector for each of that point.
No.
So it's just more metal, I would
Yeah.
say. It's just more of everything. You just got more of that. So that's why it makes it more expensive, the system overall. But the people still, who wants really reliability, who wants the system running, especially in mining, in the big trucks, they use this because this system also, I would say, they are less sensitive to contamination. Then if you see these plungers are very tight there. So even if you have like solid additives, up to 5% might be good, like solid additives for the series progressive system. But if you got more particles, bigger particles, different size particles, it actually from like in a year or two, it may jam actually the system. Just it can wear out the plunger inside there.
Yeah, right.
So the system will fail like sooner rather than the injectors. And then you gotta spend more time on troubleshooting, and then you gotta replace the whole block. So it adds up on time. And in mining, it's all about time. So you gotta save time on maintenance. So that's why the injectors are faster in maintenance and in troubleshooting. So that you just unscrew this injector, and just replace the injector, and then just can go run again.
Okay. Cool.